outline of the research. Firstly, we have the abstract. We do not explain that. We just move to the introduction. In the introduction, I will explain the definition and origin of Iwan, and later talking about the Iwan in Sulaymaniyah architecture, and later talking about the literature review and explaining several papers which studied Iwan in different regions and in different architectures. And later we will explain the gap of the research and research questions and selecting some case studies. In the second part, I will explain the methodology and the ways of reaching the answer for our questions, and later presenting results and discussing different graphs and results of our methodology. And at the end, we have conclusion and future studies. So as I mentioned, we have the abstract, we just move it. We put it here for later use. If someone has a file, they can read it. So the term of Iwan is originally is a Persian word, and later other languages they adopted this word for example, in Kurdish it is Haywan, and in Arabic it is Aywan. And Aywan or Iwan is space or a hall which is totally roofed and walled in three-sided, and open in the fourth side, open to the yard or to the garden. Actually, Iwan is used and utilized in Sasanian Empire during the 3rd to 6th century, and later it was developed and used in Mesopotamia architecture, and later it became a main part of Islamic architecture and Middle Eastern architecture. It has been used for several purposes, like for functional purposes. It was used for like a sitting area or resting area, and in some cases it was used as an entry or a passage to, and also it has been used as a linking space and transitional space between the outdoor spaces and the indoor spaces. You know that this is Iwan of Tisfun, and this is an Iwan of Amiria house in Kashan. So let's talk about using Iwan in architecture of Sulaimani, or we can say local architecture in Sulaimani. As you see, there are 3 houses which they used Iwan in their designs. Iwan is commonly used in houses, especially in Sulaymaniyah, and it's inspired from Iranian architecture, and it can be clearly seen in, you can say, in most of the houses in downtown of Sulaimani, I mean in the old part of Sulaimaniya. If you go there and walk around, you can see there are many old buildings and old houses. Most of them, they have Iwans in their, especially in the first floor of their houses. So, mainly Iwan in Sulaimaniya is located in the first floor overlooking to the yard or to the garden, and with different sizes, with different proportions, and it has been used as a transitional space and as a link between the outdoor spaces and indoor spaces, and as I mentioned, for different purposes, for different functional, environmental purposes, and even in some cases it limits the view from the outdoor to the indoor, and in reverse also. A precise and perfect designs and proportions of the Iwan can lead to penetrate the solar radiation during the desirable seasons, I mean during the cold seasons, and with a good orientation, it can be used as a shading device or as a shading element in buildings during the hot seasons and in summer. So also there are some other examples. This one is that one Dr. Amjad yesterday mentioned that it was unfortunately destroyed, the middle one. This one is, Sophie Karim's house, which is renovated and it is used. It's using as a cafe and restaurant. So let's move to the literature review. In literature review, we have several papers and researches which have done from different areas, but most of them are about the Iwan and buildings with Iwan in Iran. For example, the first one from Kakizadeh analyzed spatial fluidity of Iwan spaces in traditional houses in Bushehr, which is a semi-arid and hot area and climate in southern part of Iran on Arabic Gulf. And the second one discussed architectural and functional rules of Iwan. Symbolic meanings. And the third one, which is done by three researchers, they investigated the relationship between climatic factors and climatic rules of Iwan and energy performance of buildings. And they stated that the Iwan is rarely used as climatic factors, also climatic strategy in designing the buildings in Tabriz, which is a city in Iran, from the northwest part of Iran. Another paper, they work and examined sustainable Iwan as an important sustainable elements in architecture, especially in houses in Iran. And the last one, which is the new one, and it has done in 2018, they studied Iwan and solar energy consumption and energy performance of Iwan in different orientation and in different climatic regions in Iran, in 4 different climatic regions in Iran, in semi-arid climate, in temperate and cold and hot climates. So, those are the main papers and research that studied Iwan in different aspects and in different regions, but most of them were in Iran because using Iwan as an architectural element is very common in different parts of Iran. There is a gap in the research and in the papers. There is no research examining solar performance of Iwan, especially in Kurdistan and in Sulaymaniyah. And most of the research are far from the Kurdistan and in different climatic characteristics area. And we tried to focus on that one, which is solar performance of Iwan in traditional houses in Kurdistan and especially in Sulaimaniya and in the old part of Sulaimaniya. And also examining the effects of exposure and enclosure ratio of Iwan and the effect of that on the energy performance and the solar performance and spatial performance of the Iwan in the traditional buildings of Sulaymaniyah. So, the question is that to what extent dimensional variables and orientation of Iwan is related to performance of the space and in the architecture of Sulaymaniyah. So, as you know and you've seen in examples, the Iwans in traditional houses in Sulaimani has different dimensions with different proportions, with different orientation, especially you know that. So to what extent these variables are related to the solar performance and energy performance of the building. The case studies, we selected 22 traditional houses in the old part of Sulaimaniya. Five of them are registered in the cultural heritage in Sulaimaniya. Most of the selected buildings with A1 are oriented from the southeast to the southwest, most of them. And the height of the E1s is approximately constant, about 3 meters, somehow more and lower. And there is a variable which is dips to width. The dips, as I mentioned, the height of the E1s mostly is constant, but those two other dimensional variables, which are dips of the E1 and the widths of the E1, are different in different examples and houses. That ratio changes from 1 to 1 to 1 to 2. This means if we have an E1 with 4 meter dips, we have the width of 4 meter for the 1 to 1. But in case of 1 to 2, this means the E1 with 4 meter width, we have 8 meter wide and width. So this is a table of properties, dimensional and orientation properties of all of the case studies, which are 22 case studies. The first one is the height of the E1s. Most of them are close to 3 meter, for example, 2.8, 3, 3.2. So we consider that it is 3 meter. And the dips changes from 4, 3, 3, and with different dimension. Even we have 5 meter, and the width also changes from 3.8. We have different widths also, and the ratio. This ratio, we work on that dips to widths changes, as I mentioned, from 1 to 1 to 1 to 2, and all of the houses with A1s have different orientations. This is the azimuth angle of the orientation of the buildings. 0 is the north direction, and 180 is south direction. As you know, 90 is east, and 2070 is, I think, west. So, let's move to the methodology and explaining our tools and methodology, how we try to reach our answer for our questions. So by using two computer program, Google SketchUp and Euclid extensions, we create a 3D model with the same properties of E1s and traditional buildings in the old part of Sulaimaniya. This is the 3D model. We ignored the ground floor plan because it doesn't affect all the results. We just considered the first floor plan with the E1, which its height is constant, it is 3 meters, and the depth is 4 meters. But the only variable, we have two variables. The first one is changing the width of the E1 from 4 meter to 8 meter every 1 meter, changing by the ratio changes by 0.1. So in this case we have 11 E1s with different ratio of the depths to widths. And the second parameter is different orientation from 0 azimuth degree, which is north, and in every 15 degree we change the orientation of the models. So in this case, we have 24 orientations. So 11 multiplied by 24, we have 264 times we simulated these models in 2064 times, different times, by using Energy Plus program, which is a simulation program which is used for sustainable and energy purposes. So those are the 11, this one is just the typical one. Those are the different ratios for the E1 without considering the orientation. So our result is monthly average of incident solar radiation installation. Installation is incident solar radiation per area on 4 main faces inside the E1, which are floor of the E1, and 2 side walls, and the back wall of the E1. And we considered all 12 months, but those 6 months we considered as cold months, which are January, February, March, October, November, and December, and the rest are we considered as a cold months. So, you know that during the cold seasons and during the cold months, receiving solar radiation is acceptable and desirable, but during the hot season, it's not acceptable, and people and everyone tries to stop it. And we have an equation to calculate the results, which is, and we have an index which is annual insolation value, AIV, which we calculated by this equation. This is simply x1 plus x2. Every x is a month. The installation of results, the installation of E1s in those months number 1, number 2, which are January, February, and others, and minus, in quotation, x4, this means 4th month, and x5, so installation in cold seasons minus installation in hot seasons. All of the results are negative because by comparing both installation during the cold seasons and hot seasons, it's more negative during the hot seasons. This means getting solar radiations during the cold season is not much better than receiving or shading and stopping solar radiation during the hot seasons. This is several results for some of the case studies. For example, the E1 with D to W ratio 1:1. This means with 4 meter depths and 4 meter widths in different orientation: north, northeast, east, southeast, and south, and blah blah. We have different results, and for other 10 E1s with different ratios. We can see here we have the maximum number, which is 232. This is minus because that it's the maximum, and the minimum number, which is minus 404. We have the best and the worst cases. The best one is the E1 with ratio 1:1 in south direction, in south orientation. But the worst one is 1:2 in north orientation. Later we can explain those in different charts. For example, explaining the effects of changing E1's orientation on AVI value. in Iwans with different exposure ratios. For example, we put three graphs together to compare those together. For example, the first one is the Iwan with D to W ratio 1:1. As I repeated and mentioned, 4 meter depth and 4 meter wide and width, and 1 to 1.5 and 1 to 2. This one 4 meter depth, 6 meter wide. This one 4 meter depth and 8 meter width. So we can see here changing the orientation of the E1 with this ratio from north to south increases the AVI value. This means increases the performance of the E1, solar performance of the E1. And also from the north in other side to the south also increases the performance of the E1. But here in this case, the increasing the performance of the E1s is significantly from the north to the east. But from the east to the south and to the west is not so considerable. Also in the third type, which is this ratio, 1 to 2, changing the orientation from east to south is not important, and we can say it doesn't affect the solar performance of the E1. And in the next slide, we explain the E1's exposure ratio on AVI value, that effect of exposure ratio of E1 on the AVI value in different directions. For example, here the orientation is constant. For example, for the E1s which are orientated to the north, by changing the ratio of the front facade of E1 significantly decreases the performance of the E1. And in south, which is the green one, 180 azimuth degree, it also decreases, but it's not so significant. In both west and east, changing the orientation
is over.
Yeah, sorry, just a few minutes. It's not. It doesn't affect the performance of the E1. So it is comparing all the cases together. It can be seen clearly in west and east orientation. Changing the ratio doesn't matter, but on south and north directions significantly affect the AVI value. So this one is another graph. It is concluding all graphs and results together on a circular graph, which it's organized by different direction and orientations. And we can see the best case is 1:1 on south, and the worst one is 1:2 on north orientation. So, talking quickly about the conclusion. E1 in traditional houses in old part of Sulaymaniyah has been used for two main purposes. The first one is architectural and functional requirements, and second one is for climatic reasons. And regarding the case studies, so 82% of the case studies are in the best range of orientation, which is from the southeast to the southwest. This orientation was the best case study, based orientation according to our results, and 82% of our case studies and buildings are in this range. And the worst orientations is north-west to the northeast. Fortunately, none of the case studies were in this range. So, solar performance of the Iwans in general, solar performance of the Iwans with lower ratio and proportion of Iwan depth to width is better than those with higher proportion. And okay, 59% of the E1 were under the 1 to 1.5 ratio, and the rest was higher. And one of the main factors of choosing, according to our results and our collected data, one of the main reasons to considering the orientation of the buildings with A1, according to our results, is the solar performance of the E1s, and maybe prevailing wind and other environmental factors could affect it on that, choosing on that orientation. According to the dimensional parameters, as we explained, the E1's dimensions were different from different case studies. This may be because of the functional requirements and for functional purposes. And thank you for your attention.
Is there any question about the research?
I have one, please. Thank you for this nice presentation. Just I have only one comment. The A1 didn't do anything for you, I think, because it's only the direction, the azimuth angle, which controls the story, right? So you got, I think on slide number 16, you have the ratio of depth to width. It doesn't do anything for you, I think. This one, yes. The other one, I believe you have a figure for that. And depth to ratio, this one, go back please, the next one. No, it was another figure. Yes. So it wasn't better to just name the study as the direction of the houses in terms of north, for example, because we get more energy from just a window. If it's a window without A1, that's only.
You mean knowing that different ratios of depth to width is not important in this?
It doesn't do that much as the direction does, right?
In west and east directions, yes, they don't affect on solar performance of E1. Changing that ratio, the ratio of E1 in west and east directions, not only in that, in
south and north.
Yeah, they don't affect the AVI value, but significantly affect the solar performance of E1s, especially in south and north orientations.
Because you don't need the energy inside the E1. You need it to get inside the house. Usually we have a window on the A1 and the solar radiation enters the house from that window, which is located on the A1, right?
Thank you for your note, but let me explain something. We have 3 walls inside the A1. That walls can be glazed, and that penetrate the solar radiation into inside the rooms. And during the cold seasons, it is beneficial and it is desirable during the cold seasons, but during the hot seasons, it's not. And you have to protect that. So it's important, examine that. It's so important for climatic designs in architecture and also for sustainability design in sustainable ways. But I don't know why you said it doesn't matter. So I know you are right. Inside the E1, there is no mechanical conditioning, air conditioning, but it's important for the backward rooms. As I explained, that three walls may be glazed, and mostly it's glazed and partially may be glazed, and it affects the indoor environments inside that rooms. I hope it will be clear. Yeah.
Sorry, excuse me, I'll be very thankful if all the questions and the answers are very concentrated, please.
Okay. I am asking about what you mean by the strategy for the solar performance. Do you mean that you want to maximize the heat gain, or to maximize the other thing regarding Sulaymaniyah? This is, I think, this point will determine the next steps. This one question. Another question: do you discover? Because you studied the traditional architecture, and we know that traditional architecture is sustainable and successful for. Do you discover any pattern for the orientation, the best for the orientation or optimum orientation of Iwan in the traditional architecture of Sulaimaniya? And is there any fixed pattern for this the ratio of width and depth or length? And is there any correlation between certain orientation with certain ratio?
Yes, thank you. Very simple and quickly. Solar performance means that direct solar heat gain in winter and stopping solar heat gain during the hot seasons. You know, in Kurdistan, especially in Sulaimani, we have a very cold winter and very hot summer. Regarding your second questions, yes, we explained in conclusion. Most of the case studies, for 82 of the case studies are orientated in the best range of orientation, which is from the southeast to the southwest. And but regarding the other variables, it changes without considering the orientation. Thank you.
Thank you for your study. Can you show us the slides where you have these models? You showed maybe, I think, 6 models produced by computer. These 3D. Yeah. Now I want to see the other one. I was not, I was expecting that to make it much more interesting to compare the height with the depth. Instead of showing the same height, which don't give me any new, knowledge about how I can look at it in section, this proportion between the height and depth. Did any studies about this ratio between? And then there's another thing which I want to mention also in the Mashriq al-Arabi, in Damascus, they always have the winter Iwan and the summer Iwan. This is part of the living heritage in houses with courtyards, where they have opposite to each other 2 Iwans, one for summer because the sun is very vertical, and one in winter because the sun has an angle that you need the sun heat to be warm. Just drop it to think about it.
Yeah, thank you. Regarding the first question, we have 3-dimensional variables. The first one is height of the E1. I explained most of the heights we can say are constant because most of them are close to 3. So we fixed on 3 meters. But regarding the depths, we had to fix one of the other variables, which were depths and width of the E1. We took the average of the depths of the E1s, which were approximately 4 meters. And we change only the other variable, which was the width or width of the Iwan, to know how it affects the solar performance. I think it's clear. Thank you.
استبعدت بهيوان اما طبعا زين كبيرين هيوان لكن وانا كانوا وكيس طلعتوش بس منطقه بعد شلون كنت تقولي منطقه داون تاون آلية كان ميكانيزم كان دوزي وتو بقول لخاني تازه شلون مكان ايوان هون هون زين مرحله انتقاليه دزتانا لزور ساعتك مرحله انتقاليه اجي تناوب ماوس خارجيش بعكسه بتشصي غير يعني بتشكل توامل خاني تازه ام هيوان مكانت شو قاعد بلي بالكون بالكون تصور على قدرة خانو الاستاش معاصر يا خانو يا بلي شقيا خانو زور بي جراج دفنية يا حوشي كي دارك ما تخليك قباتي هيك تش بتشوي بكاربت بوي اسبالي يعني بو آلية كتالك بدو بو مستقبل أجل بو بتشوني ما بزاني إيش اسبالي
Okay, thank you for your questions. The question is that if we have Iwan in new architecture of Sulaymaniyah, or how we can use it in the recent architecture. Actually, our architects don't use Iwan in new designs, but they use mostly balcony. However, the balcony is totally different with Iwan because Iwan is surrounded in 3 sides by rooms, but balcony maybe have only in one side rooms and other sides may be open to the outdoor. So the shading and solar performance cannot be examined on the balcony, and the solar performance of balcony is totally different with E1. But it's our duty and your duty as architects how to interpret E1 rules and E1 characteristics and functions in new architecture, in modern architecture. In my future research recommendations stated, but I didn't mention that, we can work on more forms of E1s, we can create innovative forms for E1s to put in new architecture, to put in advanced and recent and modern architecture. Inshallah, later in our future research, we work on those types, on those forms of E1s. Thank you.
Actually, the coffee break has already started, and I'm afraid if we continue questioning, you will not find any more coffee to drink. So it's up to you. Dr. Anam, please.
I think you examined 22 examples, and those examples ranged from the best orientation of Iwan. That's because the traditional builder gains his expert by try and error, and one by one he knows which orientation is the best. So they range it from 135 to 225. And also you have courtyard house, and you have 4 orientation for the courtyard. You can choose the best orientation for your E1 because you have the 4 orientation, then you can choose it. All people, the E1 was used for family gathering during summer, not during winter. During winter they are using the rooms from the E1, entered from the E1. But during summer, instead of using the courtyard, you can use the courtyard till 12 o'clock, and after that you want some kind of shaded area. So they are using the E1 for summer, for family gathering, and that's because you have you gain all the examples within the best orientation, and you cannot go further than depth to width from 1 to 2, because you have limited facade for the courtyard. I think it's a good approach, and it can, if it's developed, you can give standard for the designers how to design the open areas by using the courtyard, because we now also using the courtyard for schools, for hospitals, for office buildings, for so much kind of buildings. So I think it's a good job. Thank you.
Thank you so much. No, it's clearly, I agree with you for most of the points. I agree that it is done by trial and error by our grandfathers. And we just examined about those variables which were orientation plus dimensional variables, the effect of those on solar performance of Iwans. Thank you so much.
Thank you, Mr. Ahmed. Actually, I have too many questions, but don't worry, I will delay them and I will ask you about them personally because we are running out of time for that. Thank you very much. Thank you all for this presentation, and thank you.
Thank you so much.
Now we go to the coffee break, please.